When machining a pocket like this and there's a raised section or an island such as this gasket face, you can have the tool remove all the material down to the top of the island, and once the tool is below the island, the rest of the pocket material will be removed around the island. The island pocket option will do just that. I'll select the pocket toolpath from the 2D toolpaths. When chaining for an island facing pocket toolpath, it's critical that the top of the islands and the bottom of the pocket be chained. This is how Mastercam will know the Z level for the top of the islands and the final Z depth of the pocket. I'll chain the top of this island, scroll down, and select propagate along tool plane, and the top of this island, and the bottom of this pocket. I'll accept these 3 chains to end the chaining. I'll select the Tool tab, and I'll reuse the 1-inch flat end mill, adding the comment to rough the pocket. I'll select the cut parameters and choose island facing as the pocket type. The default settings from the last toolpath should be fine, but I'll add 0.05 material to leave on the walls and floors, as well as 0.05 to leave as stock above the islands. This should ensure the chamfers around the islands are not machined. I'll select the depth cuts and set the maximum rough step to 0.5. I'll leave the rest of the values at their default settings and accept these selections. The cut lines show how the pocket will be roughed, and you can see that there are several places the 1-inch end mill can't enter. I'll try to fix this by selecting a new cutting tool. I'll select the parameters for this operation, then the Tool tab, select Library Tool, Filter, and for the tool diameter, I'll select less than. I'll right click in the tool size field and select S equals the distance between 2 points. I'll zoom in here and enable the option to use cursor position only. I'll select these 2 points, and I'll repeat this analyzing process between 2 points for several locations so I can decide what size cutter to use. Now that I know the smallest distance is just under 1/4 inch, I can calculate the tool size that should fit this geometry. Next, I'll now analyze the depth of the pocket so I know how long the tool's flute length should be. I'll right click in this field again, and this time I'll select L equals the length of an entity. And select this line. This length is just over 1.5 inches. I'll right click again, and I'll select R equals the radius of an arc. Select this arc, right click to accept this. Since this radius is 3/16, I can add it to the 1.5 inch length and see that the tool will need at least 1 11/16 of an inch of flute length, or extend beyond the face of the tool holder by more than 1.6875. I'll search for a tool with at least 1 3/4 inches of flute length. I also need to consider that I have left 0.05 on the wall, so the tool diameter should be less than 0.26 minus 2 times the 0.05. Because this value is so small, I know I'll not find a tool small enough to clean up the pocket all at once. I'll exit these windows and leave the 1-inch end mill as the cutter. Later, I'll use the remachining toolpath to clean up the areas where this tool could not go. In the next lesson, I'll simulate this toolpath and look